Hello everyone, welcome back to Project for YouTube channel. This is me, Sidran Anand. Today in this video, I'm going to be explaining you a really interesting and an important application of machine learning, which is customer churn prediction. Customer churn prediction is becoming such a prominent topic these days because companies like banks and even e-commerce companies, retail companies, and telecom companies are leveraging customer churn prediction to actually identify where which customers are likely to churn, so that they could focus on their marketing strategies to retain the existing customers. So that is why it's becoming really a very important business metric for companies. So in this way, this topic I'm going to divide into three parts as videos. Today's video is going to be the part one of the topic, and stay tuned for the upcoming videos as well. So let us get into the plan as to understanding how customer churn prediction I'm going to demonstrate as a topic. So, customer churn prediction using machine learning is going to be the three parts. Part one is going to be about exploratory data analysis, data visualization, and machine learning concepts. I'm going to be, demonstrating you as well by taking a churn data set of bank, and data set is taken from Project Pro platform, so you can check out. So, I'm going to be explaining you the different machine learning concepts, in order to build firstly machine learning models. But before that, we need exploratory data analysis to be done, so that to identify the various features present in customer the churn data set. So because see, the data set is going to be consisting of various features, and using those features only we're going to actually build machine learning models, because those features are going to indicate how likely is the customer going to churn or not. By the way, churning is meaning that the customer is going to discontinue his or her service. So that is very important to identify in the early stages in of the company itself, because I feel that any company, in order to continue with the customer or to build long lasting relationship with the customer, the company has to identify which customers are going to discontinue or have already exited. So this can be done by seeing their past history, their various past transactions, some of the demographics of the customers which are recurringly churning. By using that, we can we can actually build ML models which will automate this process of churning, because we need not manually identify leveraging KPIs and all that to understand how which customers are churning and how likely they are. But by using machine learning, it will actually automate our work. And more to add on to that, definitely we can leverage machine learning models by building them, but then there are even more faster tools like auto ML modules, like leveraging PyCaret, which I'm going to show in the part 3 of the video, which will actually automate the entire process of machine learning workflow by even helping us to gauge which evaluation needed to go about and how. So this customer churn prediction, be this use case or any use case of ML, will actually depend on the quality of the data, the various features present in the data, and in seeing that scenario only we can understand which machine learning model to select and go about with. So in the first video, data visualization, machine learning concepts, and EDA is going to be covered, which is today's video. Part 2 is going to be talking about ML model selection evaluation for customer churn prediction, and third one is going to be done using PyCaret auto ML model. So let's begin. Basically, let me show you the data. This is the overview of the data set which I'm going to be using for building the model. So when we have 14 features or 14 columns over here, and there are around 10,000 records or rows present in this data. So this data set has features like, you can see here customer ID, surname, the geography, gender, age, tenure, balance, and so on. So we're going to operate on this data set. We're going to feed that data set over here to this Google Colab environment. So before doing that, we should need to import the necessary libraries, pandas and numpy for data manipulation, because we're going to load the data set as a data frame. So in order to manipulate from data frame, we need these libraries. Then matplotlib and cbot for data visualization, because we definitely, as a part of exploratory data analysis or EDA, it is very important for actually understanding what the data is all about, to understanding the various correlation between the features present in the data and so on. By the way, coming to the next slide, which is what is the problem statement which I'm going to be working on. It is basically a bank which has been observing a lot of customers closing their accounts or switching to competitor banks over the past couple of quarters. So basically, we have a bank data set, and the bank has been observing that the customers are actually exiting. So the bank has to understand that what is actually causing the customers to churn. What are the reasons? So in order to understand that, the bank has a data set of details of customers. Like I've shown you the data set has features like the estimated salary, balance, how active the customer is in the platform, and whether the customer has a credit card or not, and what is the credit score of the customer, age, gender, and so on. So by taking that into consideration, we can and even the number of products the customer has bought with the bank. So by actually looking at those parameters, we're going to be the bank is looking forward to build a machine learning model to actually that can actually predict which customers are going to churn, so that the necessary actions or interventions can be taken in order to retain the old customers. So in this machine learning churn project, as I've told, we are provided with customer data with all his past transaction details, associations, relation between the data features and customers. Propensity to churn has to be predicted. So that we're going to see over here. Now, coming to this part where we have, loaded the data set, we are actually getting the overview of the top 5 records present in the data. So data.head gives us that. And coming to data.shape. So data.shape is going to give us the number of records or the rows present in the data and the number of columns. So there are 10,000 rows and 14 columns. Data.info is going to give us the overview of the data types present in the columns. We have all these columns like row number, customer ID. What is the data type associated with each column is also shown over here by doing data.info. So when you see here, integer is for the row number, age is given similarly in integer, and we have something like geography in object. So anything like in alphanumeric or string form is considered to be an object in Python. Then number of products is integer, is active member is integer, estimated salary is float. So that is the data type. To understand that, then data to describe is similar, to get an overview of the data present, but actually it gives us the statistical measures, or basically the statistical description of the data. So when I say statistics, there are different measures like count, mean, mean of all the values present in each column of the data is given. STT stands for standard deviation. Minimum, maximum value is shown. 25, 50, and 75, these percentages are indicative of interquartile range. So when you've heard of a graph which is called, or a plot which is called as a bar plot. So we use or a box plot, by the way, sorry, it's a box plot. So box plot, it uses IQR, which is interquartile range. So basically that divides the data. To understand the variability in the present the data, it divides the data into these quartiles. So 25, 75, and 50 are referring to that. Coming to data is null dot sum. Once we've identified the statistics of the data, understood how many the features are present, what kind of features are present in the data, what data types are associated with the features, time comes to understand what are the missing values and if there are missing values or not. So if there are any missing values or null values, we need to first drop those missing values or impute them. That is the first step present in any data pre-processing or cleaning which has to be done. It's the first any ML model has to is actually working on data. So the data set has to be cleaned thoroughly before actually building ML model. So that is why we are actually doing EDA and checking which features are important, what are the correlation between features, and that is also done using matplotlib, seaborn. These are for the visualizing, because when we visualize that, we actually get a clarity, a clear ratio or distribution of all the values present in that way, and we can infer insights. So ongoing is null dot sum. This actually gives us the count of the null values, the missing values present in each column of the data set. So we see that there are no missing values present in our data frame. But definitely, if there are missing values, the first step should be to drop, either to drop or to impute them. Impute as in to replace the missing values with it can be either the mean, median, mode of the value of all the values present in the column. Now, as we can see, there are no missing values present. This is how we are just plotting it. We are just getting the first 2 records of the data. That is for this understanding. Distribution of dependent variable exited. Now, this is the main part. Exited is the final, the last column of the data frame. The last column is the called as the it need not be the last, but over here we have the last column because that is called as the depending column, or the dependent column, because it's dependent on the other independent variables. Other independent variables like customer ID, surname, credit score are the parameters of the feature variables, we can say, because the model is going to with the help of all these features and understanding how correlated or what is the dependence between this feature and the dependent feature. The dependence or the relation between the dependent variable and the independent variable is going to be studied by the model. So this exited is having two classes, 1 and 0. 1 implies that the customer has exited or churned. 0 implies the customer has not exited or not churned. Now, exited means churn in our data frame. So, 1 and 0, you can see it can be either binary or multi-class as well. But we have a binary classification at hand here. So, basically, the main agenda is going to be to understand how we can leverage machine learning model techniques, EDA process, to make you understand exploratory data analytics. And most importantly, the data set is imbalanced. So, that is such a dicey concept because definitely we can build ML models on any data set. But then if the data set, what if the data set has a very uneven distribution of classes? So the concept of minority and majority classes comes in. So when we have such imbalanced data, it is very important. See, accuracy, people go with accuracy. But then we cannot go with only accuracy for each and every scenario. And that scenario which I'm talking is in the context of imbalanced data set. So you'll see after, while delving into this, in the demonstration, you will get to understand how we can actually deal with imbalances in the data. So when you have imbalanced data, do you think accuracy is the metric to go ahead with, or should we look into other metrics? And other metrics like precision, recall, F1 score, AUC, like area under the curve, ROC curves. So you might be thinking which one to go ahead with, what these evaluation metrics stand for, and so on. So yeah, distribution of coming to this demonstration, distribution of dependent variable exited. We see that around 20% of the data is showing churn. Since 20% is showing churn, it can be considered as minority class. Churn is considered as minority class because only 20% of all the classes distribution in the exited column of the data frame are actually 20%, and remaining 80% are not churning. So it is an uneven distribution of data set because this is churn is a or exited data is the minority class of it. So in order to deal with that, let's look into how we can do. Coming into this, getting the value counts. This is the Python basic Python method. That value counts will give us the count of the values which are present in each category. So 0, which means the customer has not exited, which is 7,963, and around 2,000 customers have already exited, is what is shown in the data set. Now, coming to bar plot, the different types of data visualization techniques, the different graphs which you can actually plot. So I've plotted the bar graph over here with x-axis and y-axis. X-axis over here we have index, and on the y-axis we have exited, because that is the dependent variables. The dependent variable is actually exited, and or the target variable. Dependent variable is the target variable, and the other variables are the feature variables or the independent variables. This is, we can see here, this is the graphical demonstration of that. Similarly, we have the line graph. So when you want to plot between the tenure and exited, we see that the relation between the exited and tenure is also shown here. And from the graph, we can infer that lesser the tenure, more are the chances to churn. So this stresses on the fact that the companies, be it the banks or any telecom companies, have actually should focus on their marketing strategies to retain customers for longer duration or longer tenures. Because if you build long lasting relationship with the customers, that gains mutual trust, and the customers can continue with your services and products. Then churning is equal to data. To actually get the how many customers have already exited. I've done this. Then we get this overview. Then now taking into consideration the geography parameter. Geography is where the country. So we to get to know firstly what is the distribution, or the customers are from which country. Firstly, we are actually doing this. Then dot unique is actually removing the duplicate values. So we only want to know the names of the countries which are present, because they are, we know that there are 10,000 records and there may be repeating values. So we only want the unique values of the unique countries. So that is France, Spain, and Germany are the three countries from where the customers are. Now, calculate ratio is the function to actually, give us the proportion, the ratio of the anything. Like we have this data, when we are actually graphically plotting a data, we get to understand. But then in order to understand the statistically the ratio measure also, we are actually built function, and after executing that, you'll get the measure value as well, the exact value. Because some graphs may not be conveying clear results because of the color, maybe, or maybe due to the proximity of the values on the x and y labels and so on. Then count plot, you see that on the x-axis we have we have geography, which are France, Spain, and Germany are the countries, and on hue implies the color. So we have two colors, orange and blue. Blue stands for the not exited customers, and orange is denoting the exited customers. Because one is for yes, zero is for no. Then on the y-axis, we have the count of the customers. You see the customers who have churned the most are from Germany because that has the high measure in orange. And the customers which are least likely to churn are France because that has most in blue. Now calculate ratio, that is also give whatever we have seen in the graph has implied in this form. Now we see that with churn, the highest is shown in 810. Highest is shown 814 over here. So which means that 814 was the last. Germany. So Germany customers are churning the most or have a higher rates of churning. So it means that the bank should actually focus on understanding the issues faced with the Germany customers to in order to retain old existing customers. So it has to understand what are the techniques and the marketing strategies offers it is a customer can actually imply, because I can also see this customer churn prediction is all about helping businesses to retain old customers, because in that way the customers it serves as a key KPI for the banks or for the companies as well, their key performance indicators. Now from the ratios we can see that Germany has a maximum ratio. Then gender and exit, we see that the female customers are slightly higher in color, so that is why they are they're churning more as compared to males. Almost it's the same, but slightly female customers are churning more. Then we now next is to get the distribution, the graph between tenure and exit. So on the x-axis we have tenure and y we have exit. So checking in, the customers can have different tenures like from 0 to 10 years, and we see that the most customers have churned in 1 year. So after 1 year only the customers have churned. So this, and the customers which are least likely to churn are after 10 years. So this means that the customers, once they get acquainted or once they get proper understanding for long term, they have built a long term rapport with the company or the bank, they are less likely to churn. But the customers which are just new, they're not acquainted, even like be it after 1 year or 2 years, they are more likely to churn. Because they might prefer competitor banks, other services of companies, and so on. So we have to build long term tenures with the customers, what the bank has to understand. Now, calculate ratios is giving us the measures which is plotted in the graph. Now, customers with 1 year tenure are more likely to churn. Has credit card. This is another metric that was in the data set I've showed you. And has credit card is another feature. So, to order to get the correlation between has credit card and whether he is an active member or not, we get that the customer which is the active member, we see here the customer which is actually the active member have not churned, but the customers which are new have churned the most. So it means that the active members are not churning, the least active members are churning more. Now, coming, this is calculating the ratio. Customers who are not an active member are likely to churn. Now, this is a bar plot, which is plotting between number of products and is active members. So we can see here the customers which have bought the most products are more active. And the customers, so this is not actually giving us the relation between the target and the independent variable. Rather, it is giving us the relation between two independent variables itself. Because you see here, is active member and number of products both were the feature variables, because we have only I showed you the last target variable or the column was only the exited column. But in this way I have checked the the relation between the is active member and number of products, which are both feature variables. None of them is a target variable. So this also shows that there is some kind of a relation between the among the feature variables as well. So that is why this is not related to this is can be inferred to machine learning. So there is a machine learning algorithm which is naive based. So that implies that there is no correlation or there is no feature dependence. So that is not correct in our case. That is why I have not when you go when I'll be explaining later in the videos, I'll be showing you that I have not used naive based because of this reason, because there is interdependence between the variables. When there is interdependence between the columns or the features, we cannot use naive bayes, because naive bayes has an assumption that there is no feature dependence, interdependence. So that is not true in our case. So we can see here there is some kind of relation between is active, how the customer is active, and how many products the customer has bought. Now calculate the ratio is giving us the numerical measure of what the graph has conveyed. Now this is the line graph of the same the bar plot. I have just also plotted the line plot over here using the SNS, which is a Seaborn library of Python. Now, this is the bidding concept which comes. Now, this over here is for credit score. Now, on the x-axis, I have credit score, and y I have exited. I have the count of how many customers. So, this is I have the reason I've used binning over here is because when I did not use binning, the values over here were very close to each other and was a congested looking graph which did not imply anything. Now, when you actually bin them, binning is grouping based on the frequency and the count. So, when you're actually grouping them, you get a clear picture. You see that the customers who have exited the most, which is one, are having either very low credit score because their credit score or the past transactions, the past repayment of the loan capacity is very less. So they have churned the most. And even the customers which is somewhere over here in the in the mid range are churning more. But the customers who have a good score of credit, they are less likely to churn. Now, geography, we since we know the three countries, France, Germany, and Spain. I would like to get the value counts or the number of values the customers present in each country. So we get France the most, which is the France customers are very happy with the service of the bank. They are least likely to churn, but Germany and Spain, Germany is a little higher. So we can say that Germany, the most regular customers are France, whereas Germany and Spain are the customers which are we focused more on. Now, versus the active members. So we are checking which gender of the customers are more active members of the bank services. So we see that both are equally the same. So nearly both men and women are active members. So there is not much gender bias. Now, data dot columns, we see that these are the data dot columns. So these are all the columns present in the data frame, and D types is showing us the data types associated with the columns. Now, checking the inconsistent data values in each column. This is the iteration, of the previous steps which I've shown just to check the unique values present in the tenure, customer ID, and so on. So you see here in tenure, the unique values present are 218 and so on. So these are the number of years the customers are continuing services with the bank. And next is to get the overview of the data. We are dropping in this customer ID column. Definitely, I told you the feature importance is very important in machine learning because the redundant features, the features which do not actually, affect the target variable or help in actually predicting whether the customer is churning or not, definitely they can be removed because they don't fall in the goal of the problem. So we can remove them. So that is why we have dropped customer ID and the remaining features have been kept and they can be studied. The machine learning models are going to study that in order to identify whether the customer will churn, exit or not. Now, in the upcoming video, I'll be explaining you how to build machine learning models, to develop machine learning models. And for that, I'm going to cover techniques like encoding, which is, encoding techniques, machine learning concepts, selection, evaluation, and so on. And that was all about in this video. I hope I have given a very clear picture about exploratory data analysis for customer churn prediction. And stay tuned for the upcoming videos. Do check out Project Pro YouTube channel to know more. And have a good day. Thank you.